December 7th, 2024. NASA satellites capture something impossible over central Florida, a massive lake, 730 square miles of blue water, turning black in a matter of hours, not from oil, not from algae, from something far more sinister that's been waiting 7 decades to wake up. This is Lake Okeechobee, the liquid heart of Florida. For generations, it's fed the Everglades, sustained entire ecosystems, and provided drinking water to millions. Fishermen have made their livelihoods here. Birds have nested along its shores. Communities have grown around its waters, trusting that this ancient lake would remain constant, predictable, safe. But beneath its surface, something has been growing. A toxic legacy buried in the mud. A chemical graveyard, 70 years in the making. Layer upon layer of industrial runoff, agricultural waste, and chemical residue, settling into the darkness where no one could see it. When engineers made a decision to save the lake, they triggered something no one saw coming, a chain reaction that would turn pristine water into something else entirely. This is the story of legacy mud and how one well-intentioned act unleashed an environmental catastrophe that had been hiding in plain sight. The summer of 2024 was brutal. Florida's wet season brought relentless storms, and Lake Okeechobee was rising fast, too fast. Hurricane season had dumped unprecedented amounts of water across the state. The lake, already swollen from earlier rains, was approaching critical levels, dangerously close to the top of the Herbert Hoover Dike. The U.S. Army Corps of Engineers faced an impossible choice: let the water breach the aging earthen dam and flood surrounding communities, potentially displacing thousands, or open the spillways and release millions of gallons into the coastal estuaries, disrupting those delicate ecosystems. They chose the estuaries. It seemed like the obvious call: controlled releases instead of catastrophic flooding. The math was simple: lower the lake by a few feet, relieve the pressure, protect the infrastructure. Engineers had done this hundreds of times before. Standard procedure, calculated risk. What they didn't account for was what lived at the bottom. For decades, scientists had warned about the sediment layer accumulating at the lake's floor. 70 years of agricultural runoff, phosphorus, nitrogen, heavy metals, pesticides, all settling into a thick, oxygen-deprived layer of muck. They called it legacy mud, a geological record of industrial agriculture written in toxic sediment. A history book of chemical use documented in layers like tree rings. As long as the water stayed high and still, the mud stayed dormant, locked away, harmless. The lake's natural stratification acted like a seal, keeping the past buried. But when the spillways opened, everything changed. The water started dropping on November 15th, slowly at first, inches per day. Engineers monitored gauges, adjusted flow rates, and followed protocols perfected over decades. Everything seemed routine. The first week passed without incident. Then the second. Water poured through the spillways in controlled torrents, exactly as planned. Then, on December 7th, NASA's Landsat 9 satellite passed over central Florida on its regular orbit. The images it captured would change everything. Where there should have been blue water reflecting the sky, there was black. Not the green-brown of algae blooms that occasionally plagued the lake. Not the rust color of tannins leaching from vegetation. Pure, ink-like black, spreading from the southern shore like a stain, like something alive and hungry. Within 48 hours, the blackness had consumed over 200 square miles of the lake's surface. Aerial footage showed the dark water spreading in tendrils, following currents, reaching into every corner of the southern basin. From the air, it looked like the lake was bleeding, What happened was a phenomenon scientists call sediment resuspension. As water levels dropped, currents changed. The gentle, predictable circulation that had existed for years suddenly accelerated. Water that had been moving at a leisurely pace began rushing toward the spillways. And when those faster-moving waters hit the lake bottom, they disturbed the legacy mud. 70 years of settled toxins suddenly kicked back into suspension, mixing with the water column like ink in water. But it wasn't just the movement. It was chemistry. The mud layer was anaerobic, completely devoid of oxygen. In that airless darkness, different rules applied. Certain bacteria thrived. Chemical compounds existed in forms that could only survive without oxygen. When that mud mixed with oxygenated water from above, violent chemical reactions began. Sulfur compounds released hydrogen sulfide, the smell of decay. Phosphorus, that had been locked in sediment for decades, dissolved back into the water column. Heavy metals like mercury and lead became mobile again, freed from their chemical prisons. The lake was essentially digesting its own toxic history and turning black in the process. By December 10th, marine biologists were reporting mass fish deaths. Largemouth bass, the species that had made Okeechobee famous among anglers worldwide, were floating by the thousands. Their bodies covered the surface in some areas, a silvery carpet of death stretching to the horizon. Wading birds, herons, egrets, ibises, abandoned their nesting sites, sensing something fundamentally wrong with their home. The smell of hydrogen sulfide became so intense that residents 20 miles away called emergency services, reporting gas leaks that didn't exist. Water samples told a horror story written in numbers. Dissolved oxygen levels had crashed to near zero in affected areas. Water so depleted that fish literally suffocated. Phosphorus concentrations spiked to levels not seen in decades, reaching amounts that would fuel toxic algae blooms for years to come. The blackness wasn't just visual, it was chemical warfare against anything living in the water. The Army Corps faced a nightmare scenario: stop the water releases and risk flooding communities around the lake. Homes, schools, hospitals could all go underwater. Continue the releases and send toxic water into coastal estuaries, where it could devastate marine ecosystems from the Atlantic to the Gulf, destroying fisheries worth billions. They chose to slow the releases, but couldn't stop them entirely. The lake was still too high, the risk still too great. And so, the black water began its journey toward the ocean, through the St. Lucie Canal to the east and the Caloosahatchee River to the west, carrying its toxic payload toward two different coasts. Environmental groups filed emergency lawsuits demanding immediate action. Commercial fishing industries prepared for economic catastrophe, watching their livelihoods disappear into black water. Communities that depended on the lake for drinking water watched their supply become contaminated. Tourism operators canceled bookings, and scientists scrambled to understand something that had never happened at this scale before, racing to model what might come next. To understand how this happened, you have to go back to the 1950s, when the modern version of Lake Okeechobee was engineered into existence, when humans decided they could improve upon millions of years of natural evolution. Before that, the lake was wild. Its levels rose and fell with the seasons in a natural rhythm. Water spilled south naturally during wet periods, feeding the Everglades in a slow sheet flow that had sustained that ecosystem for millennia. The lake breathed with the climate, expanding and contracting, alive and dynamic. But after hurricanes in the 1920s killed thousands, engineers built the Herbert Hoover Dike, a massive earthen wall that transformed a natural lake into a managed reservoir. The water would be controlled now, predictable, safe, or so everyone believed. At the same time, the land around Okeechobee became some of the most productive agricultural territory in America. The rich muck soils south of the lake were perfect for sugar cane. The sandy ridges to the north supported vast cattle ranches. Winter vegetable operations grew produce that fed the entire East Coast. All of it fertilized heavily with phosphorus and nitrogen, chemicals that promised abundance. When it rained, that fertilizer washed into drainage canals, an engineering marvel designed to move water quickly off farmland. Those canals drained into the lake, and once in the lake, the nutrients settled. Year after year, decade after decade, building a layer of enriched sediment that grew thicker and more concentrated, a toxic savings account that only accumulated, never paid out. Scientists knew it was there. Studies in the 1990s documented the phosphorus loading, measuring tons of nutrients flowing into the lake annually. Reports in the 2000s warned about the potential for resuspension during unusual water management scenarios. In 2018, researchers even created computer models predicting what might happen if water levels dropped too quickly, showing the potential for catastrophic sediment disturbance. But the warnings stayed in academic journals, read by specialists, but not policymakers. The management practices stayed the same, following procedures written decades earlier, and the legacy mud kept growing, waiting for the right conditions to wake up. 3 months after the blackening began, Lake Okeechobee is still in crisis. The water has returned to a murky brown. Not the crystal clarity it had before the disaster, but not the apocalyptic black of those first terrible weeks. From space, the lake looks almost normal again. But that's an illusion. The damage is only beginning to be understood. Early estimates suggest over 60% of the lake's fish population was lost in the initial event. Submerged vegetation that provided habitat and filtered water has died off in massive swaths, leaving underwater deserts where forests of eelgrass once waved. The chemical composition of the water has fundamentally changed. Phosphorus levels remain elevated even now, creating perfect conditions for toxic algae blooms that could last for years, perhaps decades. The coastal communities that receive the toxic releases are dealing with their own consequences. Seagrass beds in the Indian River Lagoon are dying. Oyster populations in the Caloosahatchee have collapsed. Dolphins have been found with unusual lesions. The tourist economies built around Florida's natural beauty, the fishing charters, the eco-tours, the waterfront restaurants, are facing an uncertain future. Cleanup efforts have begun, but the scale is overwhelming. Plans to dredge the legacy mud would cost billions and take decades. Alternative proposals suggest treating the sediment in place, though no one knows if that would work at this scale. Some scientists argue the lake needs to be left alone now, allowed to restabilize naturally, even if that takes generations. But perhaps most disturbing is what this reveals about the other systems we've engineered. Across Florida, across America, across the world, there are countless water bodies with their own layers of legacy pollution. The Great Lakes have industrial sediments, the Chesapeake Bay has agricultural runoff, the Mississippi River Delta carries the chemical history of an entire continent. All of them are chemical time bombs, waiting for the right trigger. Lake Okeechobee wasn't unique. It was just unlucky enough to be disturbed at the wrong moment, to have its secrets exposed when satellites were watching. The satellite that captured those first images of the blackening continues its orbit, photographing the Earth every 16 days, creating a visual record of our planet's transformation. An impartial observer documenting changes we cause, whether we notice them or not. In those images, Lake Okeechobee looks different now, changed, scarred. A reminder that the environmental decisions we make don't disappear. They accumulate in places we can't see. They wait in the darkness, they compound with interest, and sometimes, when we least expect it, they come back to show us exactly what we've been hiding beneath the surface. The legacy mud is still there, at the bottom of the lake, waiting. Thinner now, perhaps, after being disturbed, but still present, still toxic. And the question isn't if it will be disturbed again, but when, and whether we'll have learned anything when it happens. Some legacies can't be buried forever. Eventually they rise,